In this video, we're going to look at unsaturated aliphatic molecules. We've seen saturated aliphatic molecules, so that included alkanes and cycloalkanes, branched alkanes, and they only had single bonds. But now we're going to add in another special property for these aliphatics, and we're going to talk about unsaturated aliphatics. And unsaturated aliphatics can be made into alkanes if we just react them with some hydrogen. But we are interested in these double bonds and triple bonds compared to a single bond. So a carbon to carbon single bond is longer than a double bond, and triple bonds are even shorter still. So the carbon's nuclei are pulled closer together. The bonds tend to be less stable and easier to break, and so they tend to be more reactive. We'll talk about reactions that involve alkenes and alkynes in another video later on, but right now we're interested in just what are the general properties and what do they, how would we name them? So we're going to start with alkenes. Alkenes have a double bond. So if we looked at ethene here, you can see we've got CH2CH2, and there's a double bond. So if I'm counting this carbon's bonds, it's got 1, 2, 3, 4. So all the bonding electrons are taken care of. Carbon still has 4 bonding electrons. But now we're using some of them to make a double bond. The general formula for alkenes will be CnH2n. So CnH2n, because this double bond is creating an extra carbon-to-carbon bond. And like we said in a previous video, every extra carbon-to-carbon bond costs 2 hydrogens from the general formula, or that molecular formula. The next structure that we've got here is got 3 carbons in the parent chain. So this is a prop. And it's got a double bond, and so it's a propene. All alkenes end with the suffix ene. Then the next structure that we've got here, we've got 1, 2, 3, 4 carbons. So you can tell that this is going to be a bute. But now we need to number it, because in the previous examples, the double bond is going to always be on the first carbon. There's no way to draw ethene or propene and not get the double bond going across the first and second carbon. But it is possible with butene to have the double bond either on the first carbon or on the second carbon. So in this, I'm going to count my parent chain, and if I was to count it that direction, this would be but2ene, because the double bond starts at this second carbon. If instead I was to count the other direction, it's going to go 1, 2, 3, 4. The double bond again starts at the second and covers the third carbon, so it's between the second and third carbon. So this is called but2ene, because the double bond starts at the second carbon and goes on to the third. So the next structure we've got here is 1, 2, 3, 4, and you can see that the double bond is starting at the first carbon. So this is a but1ene. And but1ene and but2ene are very special because these are isomers. They have the same molecular formula. They're both going to be C4H8, but they have different names, they have different structures, and they have different properties. When it comes to naming alkanes, naming alkanes, we prioritize the branch all the time. Like we basically said that the branch is how we decide where we start numbering our chain. That doesn't really apply to alkenes. So in this case, we've got 1, 2, 3, 4, 5, or we've got 1, 2, 3, 4, 5. So it doesn't matter which direction I'm counting from. Or it doesn't matter if I'm starting here or here. What I'm going to do is I'm going to number this 1, 2, 3, 4, 5. So those, it's going to be a pentene because it's got the double bond here. It's a pentene. But instead of counting from the other side, so if I went 1, 2, 3, 4, 5, I would have counted that way if this was an alkane, because there would be no double bond. But as soon as there's the double bond, we need to have the double bond closer to the end of the molecule. So I'm actually going to call this a pent-1-ene. Oop, I'm putting an extra dash in there. So pent-1-ene, because we prioritize this over the branch. And then it's going to be still a methyl branch. It's going to be a 4-methyl pent-1-ene. The next molecule that we have here has 1, 2, 3, 4, or 1, 2, 3, 4, 5. So this is going to be a pentene as well. And I need to prioritize the double bond. So I think it's pretty obvious that it's faster to get, or it's a lower number to count from left to right here instead of right to left. I'm going to get a 1, 2 instead of a 1, 2, 3. So this is a pent-2-ene. And I have a methyl that is here. So I have 3-methyl pent-2-ene. And so these are also isomers because they have the same molecular formula. They'll both be a C5H10, but they have different names and different structures. So that's how you're going to name alkenes and alkynes. When it comes to naming alkenes and alkynes, when it comes to drawing them, they get pretty easy. I'll just give you a quick overview of alkynes. So alkynes use the exact same naming process as alkenes, except their suffix is YNE instead of ENE. So in this molecule, I've got 1, 2, 3, 4, 5. So this has got pent, and I'm going to count to give me the triple bond here on the lower numbers. So it's going to be a pent-1-ine, and the YNE means that it's a triple bond. It's going to be C5. It would be H, would be 2 times 5, so 10 plus 2 if it was an alkane. It'd be 5 times 2 if it was an alkene, but this is actually costing another 2 hydrogens because it's a triple bond. So this is going to be C5H8 because 2 times 5 is 10, minus 2 is another 8. The next one here, got 1, 2, 3, 4, 5, and so this is a pent-ine. So this is going to be a pent, and I'm going to go 1, 2 because that's going to give me a lower branch for, or a lower number for the triple bond. So it's a pent-2-ine, and I'm going to get a methyl coming off of my 4th. Ooh, I'm writing too small here. 4-methyl pent-2-ine. Over here, I've got 1, 2, 3, 4, 5. So this is an ugly structure that's not drawn actually particularly correctly because it's a blended structure of condensed and line structural diagrams. But you see some stuff like this. What I want you to see in this is that we get the end of lines look like this. And so sometimes you'll see like a thing like this. This would be a carbon, 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 carbon. So it's not always like kind of a jagged line. I like to draw them that way usually. So I've got 1, 2, 3, 4, 5, and this is going to also be a 4-methyl pent-2-ine. So these are actually the same molecules. They're the same molecules. They have the same name. They are drawn differently, but those are not isomers in this case. Those are actually identical molecules. I'll make another video on drawing some of these structures. It'll be much shorter because it's pretty easy to draw them.